In this video, I'm going to explain how you can figure out what the products of a double replacement reaction would be. Not if that reaction will actually take place or not, that's going to be for a later video. This one's just going to be, how do I finish this reaction? How do I go from having only reactants and no products? What would those products be? So since this is a double replacement reaction, we have to start with two compounds, and that means we have to end with two compounds. These are ionic compounds. This is a metal. That's a nonmetal. This is a metal. This is a polyatomic ion. So what I recommend you do is label each one. Aluminum is a metal, which means it's a cation. It's only going to lose electrons, so it's going to be positive. The chlorine is an anion. Chlorine is always negative, so I'm going to label that with a negative. Calcium is also a metal, so it's going to be the cation. It's positive. And then sulfate is a polyatomic ion that is negative. So now that I've labeled them, I can figure out what would go with what in my products area. I can't get two positive things to come together. It's like trying to bring two positive ends of a magnet together. They're going to push each other apart. So I know I'm not going to have aluminum bonding to calcium. But I know that aluminum is going to have to end up with something other than chlorine. It can't end up with calcium. That means it has to end up with sulfate. So I'm going to go ahead and write SO4 here for sulfate. But the problem is, this formula was written because it knows aluminum's charge and chlorine's charge, and it took 3 chlorines to 1 aluminum. We have to do the same thing over here. So we're going to look up aluminum's charge. It's positive 3. Sulfate is negative 2. Those do not cancel each other out. So we need to adjust how many of each we have to make it add up to 0. The lowest common factor between 3 and 2 is going to be, multiple, is going to be 6. I'm going to need 2 aluminums to make this a total of positive 6. And I'm going to need 3 sulfates to make this a total of negative 6. But in order to have 3 of these, I have to put the whole sulfate in parentheses and put that 3 on the outside. So now this is the formula for one of my products. I wrote the cation first because it always has to be written first, and I wrote the anion second. Now I have one other product. It's also going to be an ionic compound, and since I've used aluminum and sulfate, I've used these, the only things I have left are the chlorine and the calcium. But we have to write the cation first. Just like calcium came first in this compound, calcium has got to be written first in the product, and then we're going to bond it to chlorine. But we don't know if it's going to take 3 chlorines or not, so I can't just copy that 3 down over here. What I have to do, this was positive, this was negative, so I have to look up their charges. Calcium is in the second column of the periodic table, so it's positive 2. Chlorine is a halogen, it's negative 1. They don't cancel each other out, but what I need to do is put a second chlorine so I get a second negative charge, and they'll cancel each other out. Now I have correct formulas for the products. We see that we started out with aluminum and chlorine. We end up with aluminum and sulfate. But you notice how there's a 2 here and not over here. That's where you would come back and you would balance this equation with coefficients. And I can go ahead and do that. We've got aluminum, chlorine, calcium, and sulfate in this equation. I have 1 aluminum, 3 chlorines, 1 calcium, 1 sulfate. That 4 is part of sulfate, so it's still just 1. Over here I have 2 aluminums. See that 3 on the outside? I have 3 sulfates, 1 calcium, 2 chlorines. If we think about MnHO, I'm going to go ahead and write that down, MnHO, we would start with any metals that aren't balanced. This metal is balanced, this one is not. I need to fix that. So I'm going to put a coefficient of 2 in front of the compound containing aluminum. When I do that, that's going to change both of the things in that compound. So this becomes a 2, and then the chlorine becomes a 6. So I've fixed that. The next thing I should fix is polyatomic ions. That's this right here. I have 3 on the product side. I only have 1 on the reactant side. So I need to put a 3 in front of the compound containing sulfate. If I put a 3 right there, that changes a metal that had previously been okay and my sulfate to make them both 3. But I'm going to go ahead and keep going down the MnHO list. I fixed the ions. Now let's see if we've got a non-metal other than hydrogen or oxygen. I do. I have chlorine. I only have 2 over here, and I have 6. They come in 2s. In order to make this become a 6, I have to put a 3 right there. That's going to change calcium and chlorine. I get the 6 I wanted. I now have 3 of these. So the last thing we do is go back and check. 2s, 6s, 3s, 3s. So this is a 2, this is a 3, this is a 1, and that's a 3.